Welcome to the first presentation in our series on coronaviruses. Why am I sharing this piece? Knowledge is power. Information is liberating. Education is the premise of progress in every society and in every family. It is more so in these days of so much panic and fear. It is my sincere hope that this information that I'm going to share with deep insight into the viruses would help to power your courage and calm your fears, that it would help to understand a little bit about viruses, exactly what they are, how they work, and how we respond. There are going to be 3 presentations, and this is the first in the series. In this first presentation, I would cover what a virus is. I'll present the details of what is a virus, and I will explain how they infect their hosts, what makes a virus contagious or non-contagious, and also what happens when you get a virus. How do you react? And there'll be a session on how to kill viruses. In other words, how you can inactivate them, because you really can't kill what's not alive. And I'm hoping that also by knowing how your immune system fights, you will not panic so much. I'm hoping that also everyone is take reference from the CDC guidelines and the WHO guidance and the presidential guidelines to be able to keep safe and weather through the storm. Do not fear, the human immune system is formidable. All right, our first slide is on what is a virus. A virus is a particle that is not living. It's a piece of non-living particle that is able to infect living cells. In other words, it has a piece of nucleic acid inside of it, like here. And the nucleic acid could be DNA or RNA. In addition, it has a protein coat. So every virus is a nucleocapsid. We call that protein coat a capsid. So there is a nucleic acid and there is a protein shield around it. Some viruses would be enveloped. So they would have, in addition to the protein coat, they would have a lipid envelope and sometimes another membrane which they derive from their previous host. So here you can see many examples of viruses. Here you see the vaccinia, the herpes, rhabdo, and you must have heard about Zika, about Ebola, about Lassa fever. All of these are viruses, and what they all have in common is that they have a nucleic acid, it could be RNA or DNA, and then they have a protein coat. Some of those viruses are called naked viruses if they are just bare nucleocapsids, like the virus that causes the common cold, adenovirus. And they are called enveloped viruses like the flu virus and like the coronavirus. Now, how many types of viruses do we have? There are 7 classes based on the type of nucleic acid they have. And I think this will probably interest microbiology students the more. But the virus of interest today is a single-stranded plus RNA virus here in the coronavirus group. So a close-up on the coronavirus. So this coronavirus is a group of viruses that you find most times in animals, and you would wonder why. These animals that act as reservoirs for coronaviruses do not mount the appropriate immunity to wear them off, to clear them. And so over time and through the years and ages, they become like partners. They just carry them and they don't kill them. Classic example is the bat. So many coronaviruses are found in the bat. There are 4 types: the alpha, the beta, the gamma, the delta, and all of these can infect various animals and humans. The current coronavirus, you can see, everyone knows, is called corona. Under the electron microscope, looks like it has a crown. The crown is actually because of the spikes, the papillomas or the spikes. This spike protein is what determines what host the virus would infect. And inside here you have it has a helical, or if you like, sort of spiral capsid. So its protein coat is helical in nature, and inside it you have the RNA genome. The question has been raised, is this novel coronavirus, was it engineered? Is it natural? Spent many hours reviewing the sequences deposited in the gene bank and reviewing all of the articles published to date on this virus. And my conclusion at this time is that no, it is not likely, because I can't see insertion elements around the mutation that has occurred in this virus. But that is not to say it's conclusive. But what is important is that all of the epidemiological data, molecular data that we have, track all of these viruses to Wuhan, China. There is a consensus on it. This virus, this particular novel virus, belongs to the Nidovirinae, and that is the order of the viruses. For those who belong to the group called Nido, this is your virus, apparently. All right, so it's a Coronaviridae, belongs to the family Coronaviridae, and it's a beta coronavirus. That's its genus. Now, what else do we want to know about this virus? Two things stand out. This virus shows a mutation in the spike protein. Remember, the spike protein is what it uses to hook on or bind onto the human receptor. This particular virus appears to have mutated so well that it binds with great affinity, high affinity, to the human receptor that it would anchor on. And the variability on the spike gene is worrisome, and that's actually one main reason that it can go so fast. So this coronavirus has the largest RNA genome we know in nature, and what that means is that it's capable of encoding multiple proteins and products. That's one reason, really, it can cause so much disease. It can overwhelm the hosts. And here you can see from this phylogenetic tree where this particular virus belongs, and it clusters here with, this is our novel virus right here, is a COVID-19. This clusters very closely with the bat spike sequences. So we think that it came directly from bats and not from snakes, as they had said earlier on. It's quite related to the severe acute respiratory syndrome virus that broke out in 2003. So everyone is wondering, why is the novel coronavirus so contagious? The extent of spread of the virus, who it affects, the tissue that it affects, we describe that as tropism. So tropism is the measure of which cells the virus can infect, and of course which host. So we have host tropism and tissue tropism. It is determined by two things: the receptor to which the virus binds and the transcription factors that would allow the virus to replicate. So if you use a hepatitis virus on the skin, it will not be able to penetrate skin cells where its receptors do not exist. So it takes two to tango, even in the world of viruses. For this coronavirus, the major receptor is the human angiotensin converting enzyme 2. The human angiotensin converting enzyme 2, and you would wonder, where is that found in the human body? It is in your respiratory tract. It's in the trachea, in the bronchi. It's in the lungs. It's actually found bound on our epithelial linings. So it is widely distributed in the humans and has a lot of activities. Sadly, the mutation in the new virus, in the novel virus, in the S gene, allows it to bind very well. It optimizes it to bind tenaciously to the human ACE2 receptor. Now you know why this virus is contagious, and you also can deduce where it can infect. So who can get the virus? Who can get the infection? Remember, I'm not talking about who can get the disease. You can get infected and you get well. In fact, infection is not bad. It is the disease that is the bad outcome. I'll explain later. But who can get the infection at this point? What is the viral tropism? What is the host and the tissue? Well, the sequence analysis of this particular, of the spike of our novel virus shows right here. You can see this is the new virus that has emerged. This virus, and it compares 77% with the SARS virus that broke out in 2003. Of course, it's 100% like itself, but it is 97% similar to the bat virus. That's why we think it emerged from the bat virus. But you're wondering, in this heat map, it shows us that its closest relative is the bat. And it shows us also who it can infect. You can see that it really is not going to affect the bovine, the camel, and all of this. So it's not similar to the spikes that would infect all those other animals. It seems to be very well evolved for humans. So what is the implication of the viral tropism? It means you can get it through the nose, through the oropharynx. It means your eyes, wherever you have the epithelial lining, all of the orifices to the outside, your eyes, your nose, your mouth, gastrointestinal tract, even the anal cavity. People have had gastrointestinal reactions to this. Like some people say, oh, we feel like we have a flu, a stomach flu, and things like that. So it can go in any of these places. But what we worry most is the respiratory tract epithelial linings, where this virus can easily attack. So you can get it by inhalation, by touching your eyes, by touching your mouth, and so on. But the worst syndrome of this virus is the respiratory effect, where it causes damage in your lungs. And when it gets into the lungs, your body system reacts and causes that damage. So now, who can get this virus? Are young people immune to the infection? Now you know the answer. Anyone who is a human and who has the ACE2 receptor is susceptible. That means all of us can be infected. Please, everyone should heed the CDC and the presidential guidelines. Go to the website if you're not sure, but it's very simple hygiene. Wash your hands, don't touch your face. If you're a health caregiver, please pay attention to this presentation. Don't touch your eyes. Wear your safety goggle if you have one, or just your regular glasses. Don't just wear your mask. Wear the gloves, of course, all your PPEs, and I am so happy that the government is providing those. This virus has a mutation of 12 nucleotides in its spike protein that empowers it to bind very tenaciously with high affinity to the human receptor gene. This is why we have the contagion that is spreading so rapidly. So what happens when you get the coronavirus? What does really your body do to it? When it enters your cell, it goes in by binding to those receptors I described earlier on. And this is what your lung cells would look like. These receptors are distributed all over your respiratory tract. So here you have one virus here that is binding to the receptors lining your cells. And this is what happens indeed when it gets into the host. So when it gets into the host, so what happens? Sometimes it would go directly through the receptor-mediated entry, and we have seen that this particular virus can also cross the cytoplasmic membrane without necessarily going through the vesicle or the pH-mediated entry. So the attachment, then it goes into the host. This can go in. You have the vesicle form. In most other viruses, the drop in pH allows it to open up and release its nucleic acid into the host cell. For this particular virus, the new virus can enter into the host even through the cytoplasmic membrane, not necessarily through the, it fuses with the membrane because it has its own membrane, and then it drops into the cell and it releases its nucleic acid, its RNA, the large RNA, which is 29,811 nucleotides long. Then this very complex transcription system will ensue, and it will make several proteins, including the replicase that it uses to make copies of itself. And then it will exit your cell using the budding process. So Is it possible to target the coronavirus at the point of budding in the Golgi bodies of a cell? This is something that scientists are researching because it goes inside your cell and where it hides to multiply. If we can block it, that would be great. So after the virus has replicated, this is what you get. So one single cell in your body would have thousands of these virions, an intact infectious particle, and they are ready to leave the host cell. So for one single cell that is infected, they're able to use your cell like a factory to produce multiple copies of the virus, and then it will exit the host. And as it buds out, it infects neighboring cells. So what do you feel when you get the virus? The very first feeling that most people get without knowing that they got it is a little irritation in the throat. So if the throat is always moist, then you're not likely to get it. You drink, you hydrate yourself. You would produce mucus that would trap the virus and wash it down, and you digest it away. But if you don't, and sometimes you just can't avoid it, you inhale, then you have a little irritation in your pharynx. You would have some sneezing triggered because your body soldiers detect its presence and then they want to remove it. You have the sore throat. Some people don't develop a sore throat, just have mild irritation that then goes away. But then your body would react to it. And eventually they see the ground glass opacity if they take an X-ray. So let's take a close-up at what it does when it gets into the system. So how does it really cause disease? It does two things. Number one, it provokes your immune system, and it makes the macrophages, the alveoli macrophages, causes them to degranulate. They make pro-inflammatory molecules that would make you to recruit help from the rest of your system because they detect the invading viral particle. So it is that degranulation really that leads to people developing pneumonia. That's what damages the lungs as the macrophages respond and they are not able to ward off the pathogen. So you have a repeated cycle, and that's what leads to the damage. But this is gradual, it's progressive. So this particular virus is able to evade our immune defense. It does it in multiple ways. We know that it makes endonuclease with what we call the endo-U for short, that it uses to block interference. That's the first thing we do when we detect a virus. Our cells will produce interference to protect other cells. The affected cell will produce that to shield other cells and inhibit the virus from multiplying. This virus produces a protein upon entry that cuts up, that antagonizes the activity of the interference. So that is one main reason this virus is to be feared. It's also able to evade our detection system. So it's able to hide and it's able to attack. So it has both defensive and offensive measures against our immune system. It is a very strong and powerful virus. So the human fights on. We have different ways of halting and arresting the progression of this disease. But in some individuals, especially if you have underlying cases, and that's what the media has not been able to really explain. Most people who go to this disease, they are individuals, one, who cannot mount appropriate defense. Even some cases when you do mount those defenses, producing interferons, producing all of those interleukins, the chemokines that we use to recruit our defense cells, even when you do that, it's able to evade them sometimes and also fight back. It degrades some of our defenses. But children don't have this disease as much, but they can get infected, note, and they're able to ward it off. The reason they don't have pneumonia like the older people do is that perhaps they do not mount such strong immune reactions against it, sufficient to clear out the virus. So you make, upon entry, pro-inflammatory compounds. So inflammation occurs and you produce inflammatory compounds. So that's what leads to infiltration of fluid into your lungs. So if you take Tylenol, for example, or any of those medications when you're beginning to sense the fever, you would be able to reduce the signaling that leads to severe inflammatory response. And that's what would calm and slow you from developing pneumonias that would require all of these respiratory help that they're looking for, that is in acute shortage. So infiltration of the macrophages, massive inflammation, and degranulation, these are the things that lead to the damage in the lungs. So you can actually halt this and reduce the impact of the cytokine storm and the inflammation that follows. You can reduce that by taking anti-inflammatory compounds like Tylenol. So how can we kill the virus, if you like, before it gets to you? Killing the virus before it gets to you. In other words, how do you ward it off? How do you deactivate the virus? Here's what we know, that the coronavirus spike protein, the polymer, is key to the viral entry. In other words, and that's what makes it bind to your own host cells. That's what determines cell-to-cell spread and the tissue tropism of this virus. We also know that coronavirus entry into our cells is not necessarily pH dependent, and so it can cross the plasma membrane, not just through the endosomal routes. So there is requirement for the cleavage of the SARS-CoV spike, and you'll wonder, what is that? I am not going to bother you with that mechanism of how the virus enters through the endosomes. But all of this make us to know, and as we also already have seen, the structure of the virus. So here is what we know we can do to prevent the virus and block it. Avoid contact and exposure to the virus. And that's why they're emphasizing social distancing and basic hygiene. Please listen and follow those, and you will never go wrong. The second thing I recommend is that you can destroy the virus spikes. It's a glycoprotein. You can destroy those spikes by washing hands with soaps. So simple detergent, dilute soap. It doesn't have to be anything sophisticated. It does not have to be antibacterial. So any soap at all will help to remove the viral coat. And when you remove the coat, you peel it off, then you have removed the papillomas, the spike, and then it's not able to bind to you. Even if the nucleocapsid remains, that is, it loses its infectivity. So it's no longer an intact virion. Alcohol-based antiseptics is also useful. Anything that can react with lipids or fat would be able to deactivate the virus. So you need to disinfect surfaces. Don't spray your house with a lot of antimicrobial things and disinfectants that will injure your own immune system. So you wipe the doorknobs, countertops, wristbands, mobile devices, and you don't have to be frantic about this or fret over it. Just use mild dilute soap to wipe as you go. It would emulsify the fat and eliminate the envelope, and so it will not be, you won't get the virus. Do not drink vodka. It's going to hurt you so much without really impacting the virus. And the vodka will go through your GI tract and it's not going to go into your lungs to help you and protect you. So do not drink vodka. Some people are taking copious amounts of vitamin C a little too late, and that is not recommended. Use your normal dose of vitamin C and get all the fruits you know. Do not be afraid. Relax, because when you're afraid, your immune system is unable to function well. It will not be able to recognize the virus when it comes in. Drink tea. Tea has anti-inflammatory properties, and it's quite relaxing. Enjoy your smoothie to reduce inflammatory reactions. And if you think you've been exposed, maybe you should take Tylenol to block inflammatory signals, like I said earlier on, and then just quarantine yourself. Go into, stay home, simply put. Why you must not panic. Our immune system does fight back. We have very sophisticated immune system. First of all, we have the physical barriers that will protect you from the virus. So the first time you come in contact with droplets, how this virus spreads through droplets, it's not airborne. It doesn't remain in the air for a long time. So open your windows and let the air current go. So open the the door to the window to your cars and let air flow. If you have a visitor or you have a passenger who sprays aerosol when they talk, just wind down, don't use the AC so that you can move the viral particles. It doesn't hang up in the air for a long time. So, but we have physical barriers, folks. The human defense is formidable and a great fortress. These include the mucus that you produce right here in the epithelial lining. So this mucus protective will trap the virus and wash it down. And should it manage to go through all of these defensins and tight juncture that we have, epithelial cells and hair that flushes out, trap and flush, if it manages to go beyond the physical barriers, we have the secondary level, our innate immunity. So we have macrophages that would detect this virus. They would sense it and we have dendritic cells. They have special receptors that they use to tell when a stranger, an invader comes in. When they detect it, they would recruit pro-inflammatory, they will secrete pro-inflammatory factors, chemokines, some cytokines, and those will bring in some more body soldiers to fight and degrade this virus. They come in and they block it. So we have the RIG1 like receptor in the cytosol that helps to stop this virus from replicating if it gets in. So we arrest it, we stop it, bind it, and we kill it, we degrade it when we detect it. The human body is able to ward this off. So if you get the infection, you are not necessarily going to develop the disease. You would fight, except if you have underlying cases. Why is staying home good for us? But why is it that we do not need for it to be too long? We don't want to extend it for long. And the answer is herd immunity. Your body makes very good and powerful immune response to the virus, and this has been shown to clear out the virus, so which is a good thing. So that means that people who encounter the virus, they get rid of this virus, so you don't become a carrier. That has been represented on the media, and so many people have been confused by this. It means that after you have encountered it, 14 days after, if you have not developed a disease, it means you have killed it. It means your immune system has destroyed it. So you are virus free. So we should not stay home just because we're all afraid. And the good thing is that you develop immunity. It has been shown that people who recover from this disease develop immunity. So you are, when you're infected, you are protected when you recover. For those who who eventually get ill and recover, they also have the immunity. We need to grow the herd immunity. That's the other reason why staying home should not be overextended. I'm hoping that everyone would agree this is not a controversial point, and it is not a Trump issue. This is pure science. How will the society develop herd immunity? You would wonder, what is herd immunity? It's population immunity. It is group immunity. All of us together. The higher the population immunity, the more resilient our societies will be. If we all hide in our homes today, America will live to fight tomorrow. If you run from the battle today, you will live to fight tomorrow. And fall is not too far away. The next winter is around the corner, and it would mean that Americans will be susceptible. However, if we let young people, competent individuals, immunocompetent persons, to go out, confront the virus, fight it back, and get well, then we grow our herd immunity. Older people who mount very severe reactions that damage their lungs, or who have compromised immune systems that do not conform or are not able to fight this virus, should stay home. They are the ones who should be quarantined, not everybody else. In fact, it is my personal opinion, an expert opinion, that the Chinese success in warding off this virus is in part because of the herd immunity they developed, not just from the lockdown. Remember when they let no one in? During that time, populations and populations and masses of people were getting infected and they were recovering. So no one has measured the population that has the antibodies. Even in the US states and communities, we do not know the ratio of those who have been exposed and who now have the immunity. So it is time to move from just detecting the virus to doing a quick assay to seeing how much of our population has the immunity, the protective antibodies that against this virus. And that's what's going to help us fight well. Some message: the threat is real. Everyone can get it. The virus is novel. It's powerful, but our immune system is greater and more powerful. It's a formidable fortress indeed. I didn't go into the details, but if you want to know more, join my class. I will be teaching this next week in my microbiology class. Everyone has a role to a role in this fight against the virus. We need to prevent it, block the virus from going in using simple hygiene. We need to protect ourselves, protect yourself, and protect others. It is a one world. We all have the receptors, so there is no one to be spared. You persist in what you're doing, keep at it, follow all the guidelines, and you will be just fine. Do not be afraid. The only thing to fear is your very own fears. And that's the end of our presentation one. My name is Duto Isiabu, and I am one of the founders of Neighborhood Scientists. I am a professor of microbiology at Florida Atlantic University, and it's been my huge honor to share a little insight about this virus and hope that your fears are calmed and powered your courage. I'm hoping that this helps you respond well, you and your family. Stay well and be okay, protected.